Hello everyone, welcome back to another episode of our home renovation journey. Quite a number of you have been asking through comments and private messages on our social platforms for a video on our network setup. So, in this episode, I'll walk you through our network design and planning process and explain why we decided to go with Ubiquiti, which is not something you often see in residential HDB flats. Just a quick disclaimer, this setup is very different from a typical consumer level system that use the devices provided by ISPs. So please do your own research before committing to Ubiquiti, as your experience may vary depending on the equipment you choose. What you're seeing here is Ubiquiti's Design Center, which lets you upload your actual floor plan, mark out concrete and partition walls, doors, and place equipments to visualize coverage and more. This is our actual HDB floor plan. To start, click the button at the top left to upload your floor plan. Name the project, then drag and drop your HDB floor plan into the box, and voila! Once uploaded, you will need to set the scale. For example, our balcony is shown as 2900 mm, which is 2.9 meter. Click Change Scale at the bottom left, then left click and drag a line across the 2900 mm reference marking and set the scale to 2.9 meter. The app will automatically calculate the rest of the floor plan measurements. Down here, you will find options like Select, Hand, Draw Walls, Draw Cables, Undo, Redo, and Place Devices. First, we'll need to draw the wall to make sure the signal strength calculations are accurate later on. When you select that, you will see options such as concrete wall, dry wall, glass, wooden door, etc. Different walls reduces signal strength differently, so it's important to match them to your home's actual structure. We'll use concrete wall for structural walls. These are typically shown as thick black lines in the HDB floor plans. The remaining walls between rooms are usually partitions, so we'll select drywall standard. Just pick the wall type, left click, and trace along the floor plan. I'll fast forward this part to save time. Don't forget to draw the doors too, since Wi-Fi strength is very different when doors are closed. Once that's done, we can start placing devices. The device list is arranged logically according to the connection flow. For example, gateways, switch, Wi-Fi access point, cameras, storage, and so on. We will begin with the gateway, since we want to be 10G ready and also run CCTVs around the house. We needed a gateway that supports this while also offering video storage. That's why we went with the Dream Machine Pro Max. Now, you might be wondering, what's the difference between the Dream Machine Pro, the Dream Machine Special Edition, SE, and the Dream Machine Pro Max? In simple terms, with IDS and IPS enabled, the maximum achievable speeds differ across the models. The SE comes with 2.5G Power over Ethernet ports for powering compatible PoE CCTV directly and one hard disk bay for video storage. The Pro Max, on the other hand, has the highest throughput with IDS and IPS enabled, plus 2 hard disk bays. However, do note that the Pro Max does not come with PoE ports, so you will need a separate PoE switch. In our case, we choose the Pro Max 16 PoE, which fits neatly into a 3-unit server rack in our DB box area. Prices shown here are in USD, and local prices may be slightly higher due to shipping and transport costs. Next, we'll need an access point to provide Wi-Fi around the house. The most common method is mesh, placing a router in the living room and another in the middle room to extend coverage. Another option is using in-wall access points connected to LAN ports that HDB provides in each room. The last and least common method in residential setups is a ceiling-mounted access point. That's the route we took, as ceiling-mounted APs typically provide the best coverage while keeping things clean and neat if installed properly. There are pros and cons for each setup, but one thing to take note of is to never place your router or access point, the device providing Wi-Fi, in an enclosed area such as the DB box cabinet or inside your TV console. This is a really common mistake made by consumers which is not stressed enough. As mentioned earlier, walls, glass, and wood affect the signal strength. Placing a router or access points in an enclosed cabinet significantly reduces the effective strength, which requires you to add another point to mesh and improve the overall coverage. Similarly, having multiple devices spreading high signals might be counterintuitive. This is slightly more complicated, but if any of you are interested, there are lots of information and discussion on online forums. Anyway, going back to the mesh setup, it will typically require the routers to be placed in an open area for better signal coverage, which will take up space on your TV console and desk, while also requiring it to be powered via a power point, which can be messy if you are going for the clean, minimalist look. Going for the in-wall access point is a cleaner approach compared to mesh, but the in-wall AP might produce more heat, especially since it has to be connected to the LAN ports in the room, which is typically just beside the windows. The ceiling-mounted route which we went with would require you to plan the cable routing in the early stages before false ceiling goes up and are typically more expensive compared to conventional routers. But they do provide the best coverage while taking up minimum space on the lower levels. We went with the U7 Pro XGS, a ceiling-mounted 8-stream Wi-Fi 7 access point that supports up to 10G speeds. For most households, you won't actually max out 10G, but with lots of devices such as smart hubs, TV, fridge, washer dryer, smart lights, IoT devices, the extra bandwidth spread across everything, ensuring smoother performance. For security cameras, we chose the G5 Torrent Ultra, a 2K PoE camera with night vision and AI detection. We went with PoE cameras to avoid messy wall power points that conventional CCTV systems often need, while also eliminating the need for the camera to operate via Wi-Fi, which would be less stable compared to a direct wired connection. Now that the devices are selected, let's place them on the floor plan. As I mentioned earlier, all my equipment will be hidden in the TV box, except for the ceiling-mounted AP and the cameras. When placing the AP, the design center shows the signal strength and coverage at different spots, switching between 2.4 GHz, 5 GHz, and 6 GHz changes the coverage pattern. I will use 2.4G, 5G, and 6G here for simplicity. Generally, 2.4G has the widest coverage but slower speeds. 5G is faster but weaker through walls. And 6G is the fastest but have the weakest penetration. In my case, placing the AP in the middle of the unit gives full bar coverage, even in the master bedroom and toilets. The same goes for CCTV. You can play with placements to visualize coverage and plan your LAN cable runs in the cleanest way. For example, The CCTV in our room uses the LAN port that HDB already provided, so it's pretty straightforward. Next, we measured the cable length needed to connect the living room AP and CCTV back to the switch in the DB box area. It came to about 40 meters. Our electrician charges $130 per lamp point, which adds up quickly considering how many we require. Price aside, cables provided by them are usually of lower quality. Plus, we have heard plenty of horror stories about poorly terminated cables causing problems. So, instead, we brought a 1000 feet box of cable and terminated the ends ourselves, which is relatively easy once you get the hang of it. We only paid for labor costs to run and hide the cables in the boss ceiling, since finding time to coordinate between various vendors to do it ourselves wasn't practical. If you plan to connect your TV, speakers, or PC via LAN, you will also need a switch to split the single connection into each room. We went with the Flex Mini 2.5G for our living room and study room. It provides 4 2.5G ports after using one port for PoE power from the main switch. Some of you may ask, why not 10G since the gateway supports it? The reason is simple. Most devices like TV, speakers, and smart hub don't need more than 1 Gbps. Although my PC is 10G capable, buying a separate 10G switch just for one device would set me back a couple hundreds, which wasn't really practical. I'll upgrade in the future when I set up a personal NAS. Once planning is complete, you can go over to the ports section to review available ports and map out your connections accordingly. And that's it for part 1 of our home network series. In part 2, I will cover Ubiquiti's interface, functions, and how you can customize VLAN and Wi-Fi settings to better secure your home network. Alright, that's all for today's episode. If you like what we are doing, remember to like, share, and subscribe. And I'll see you guys in the next one. Bye!